Three boys, two girls, and a puppy are to sit at a round table. How many ways can be arranged if the puppy is to be seated between the two girls, between any two boys, or between a boy and a girl? So let's do the first one. We imagine we have our table, and there are 6 seats around it. 2, 3, 4, 5, 6. And we imagine grouping together the two girls and the puppy. So if I'm going to look at it like this, I'm going to have at some stage in my circle G, girl, puppy, girl, right? And then there'd be the boys grouped some other way. So what do I have? I treat these three as one thing, GPG, and I treat that as one object, and I arrange that with the three boys, right? So I now have 4 objects to arrange, the GPG, and boy 1, boy 2, and boy 3. And to arrange 4 objects in a circle, we know that can be done in 4 minus 1 factorial ways. So now we get to the interesting question, which is how many ways then can I arrange this GPG? Well, remember the girls are distinct. I've got girl 1 and girl 2. So here I've got G1, P, G2. I could equally have had G2, P, G1, but either way the puppy must be in the middle, so I've only got these 2 ways. So I multiply by the 2 ways of arranging the elements within my super element, and this gives us 3 factorial times 2, that's 6 times 2, that's 12 ways of doing it. So let's take a look at the second one, if the puppy is to be seated between any 2 boys. Well, we can do the same trick, kind of. Oh, what happened there? Hold on. Sorry about that. So we're going to do the same trick. If I had the puppy between any 2 boys, right? And the order down the bottom here doesn't matter, but I've got one super element, and then I've got, so one super element, and then 3 other elements to arrange. So in total, how many ways can I do this? Well, we worked it out just before with this particular combination. We know that there's going to be 12 ways of doing it from part A. But then I ask myself, how many ways could I choose these 2 boys to partner the puppy? Well, it turns out that I've got, from the 3 boys, choose 2 of them. That's equal to 3, so I have 36 ways to group any 2 boys and the puppy together. What's the last question? The last question is, how many ways can they be arranged if the puppy is to be seated between a boy and a girl? So let's put them around a circle, and we've got boy, puppy, girl, and then we'd have boys and girls down the bottom somewhere in some order. So we treat this again as one element because the puppy is to be seated between the 2 of them. So again we have 4 minus 1 factorial ways of arranging this. Then how many ways do I have of choosing who this boy is? I have, well, okay, sorry, one other thing before I do that. 4 minus 1 factorial ways of arranging these 4 elements, and then I have to multiply, of course, by 2 because I could equally have had girl 1, puppy, boy 1. But now we ask the question, and this is, of course, what we had just before. This is the 12, so we knew that. Then we have the question, how many ways can I choose who gets to be boy 1? Well, it's from the 3 boys, I choose 1 of them, and this is equal to 3. And how many ways could I choose who gets to be girl 1? Well, this is from the 2 girls, I choose 1 of them. And this means I have, how many ways in total? 12 times 3 is 36, times 2 is 72 ways of doing this. So yes, there's 72 ways of arranging the puppy between a boy and a girl. There's one last question that I almost missed, and that is, if only the 3 boys and the 3 girls are to sit at a round table, how many ways can they be arranged if the two girls cannot sit next to one another? So how are we going to do this? Well, we're going to do this with a method of complements. So first thing we're going to answer is how many ways are there to do it if the two girls must sit together? So again, we'd have like boy, 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 and the two girls sitting together. We treat these two as one super element, so I have 1, 2, 3, 4 elements to arrange again. So I have 4 minus 1 factorial ways times the ordering of the two girls, which is 2, or 2 factorial if you will. So in total, the number of ways of the girls sitting together is 3 factorial times 2 is 12 ways. How many ways are there in total to do this? Well, I've got 5 people sitting around a table, so I would have 5 minus 1 factorial ways of doing it. So the number of ways where the girls are not sitting together is 5 minus 1 factorial, take away 12. This is equal to 4 factorial, which is 24 minus 12 equal to 12. So there are 12 ways in which the two girls are not sitting